Belirleyelim. Efendim? Çok da değil. Yazın almıştım. Teşekkür ederim. Okay. So last time we made an example. Today I'll state the general form of it, and then we will do something similar to that one also. I think I wrote this last time, but I didn't prove it. I just gave one example. So the statement is the following: any n-1 vector in an n-dimensional vector space is can be written with a single term extending to that of the form A1 raised A2 raised n-1. I think last time we proved this for n equals 3. So remark last time we had proved this for n equals 2. Yani ama o ispatın fikrini veriyor. Okay, now we will do this in general. Now this is what we are going to do. Okay. Okay, so let W be the n-1 form. Here V is the dimension again. So I want to show that W can be written like this. Okay, W can be written like this. Any n-1 form can be written like this. And how we will do this? We will do it as follows. Okay. Now take a basis W, basis V1 up to N for V. Then this W can be written like this. Let's say some constant times V1 n-1, and then some other constant E2 in n, and then alpha 3 E1 E2 E4 En up to alpha n E1 yok şunu şöyle yazmam lazımdı. E1 deyince birinciyi atlıyorum. Yani 2'den başlıyorum n'e kadar. E2 deyince özür dilerim. This is alpha 1 batch. So E1 batch, E3 and so on. This one is, so you skip. Okay. Yeah, okay. This root. And then here we go up to n-1. Niye bunu yazabiliriz? Bu şu yüzden yani isterseniz burada şöyle bir şey yapayım. If I guess this is also a proposition in the book. If it's a K form, then it can be written like this. So if W is a sum of objects like this, right? V1, K, let's say R from 1 up to some number. R. R form ne demek? K form means it's a linear, okay, let's say, there is of course some constant here. Okay, see, some constant comes things like this, okay? K form demek değil mi? K tane vektörün exterior product'ların linear combination. Şimdi let's just consider one of them. Let's take one of them. V1, let's say up to K. And each VR, since this is the basis, can be written like this. This V1 can be written like this. C11, E1, C, let's say 1 and E1, which the second vector can be written like this. 2, 1, E1, 2 and En, which I have K of them, K1, E1, C, K, and En, right? And when you open this up, what you get, you see, has cross product or exterior product distributes over addition. So I can just open this parenthesis up and write this guy, match this one and so on, plus the second term match this one and so on. But we should keep in mind the following. If I choose, for example, E1 here, I should choose this guy because it will give me 0, because E1 match E1 is 0. So I can do the following. E1, I can, if I choose the first term here, then I should choose not the first term, but some other term here, like E2. And in the next one, I cannot choose E1 and E2, because if I choose E1 or E2, I will get again 0, right? Any two of them cannot equal to each other. Therefore, each time I have to pick up a different index. So what does this mean? I'll go up to, so suppose I choose the first one, and I1, the term with index I1, and then here I choose I2, and then at the end I'll choose I2. And then, of course, the coefficients in front of them will be multiplied, so you will have some constant here, and then you will have many terms. But you see, each time each time, you will have exactly k terms because we have k many terms, and these are the basic elements. So what we see, any element of this kth exterior product is a linear combination of k vectors where each vector is chosen from this base. So you just form k vectors from this basis, and you take arbitrary linear combinations of this. That's why any n-1 vector here will have this form, because these are the n-1 vectors in which can be written in this basis. Yani şu basisin elemanlarını kullanarak yazabildiğim uzunluğu n-1 olan bütün multi-vektörler. 2'den n'e kadar gidebilirim. Yani ilkine, here we skip the first one. So I have n-1 vectors. Here I skip the second one. Here I skip the third one. And here I skip the last one. And these are the only n-1 vectors which can be written in this basis. Tamam mı? O yüzden bunu kabul edelim. Okay. And then we do what? And then we do the following. Let B be any vector like this. I am just trying to mimic the proof I had done last week for n equals, no, it was n equals 3, right? So last time we proved this for n equals 3. We proved the following. Any two vector in R3 can be written as a product of two vectors, right? So, and how did we do that? We took that two vectors and we looked at the vectors so that when we multiply that vector with this form, we get 0. So that's what we are going to do. And consider the equation W which B equals 0. Geçen sefer de onu yapmıştık, değil mi? So this kind of means what? All the vectors I am looking for, which are kind of perpendicular to this n-1 vector. Okay. In case of R3, this was a two-plane, and this was a vector which is kind of perpendicular to that one. So that was the idea. So we will just consider this. Now, what is this gadget? This is just alpha I, and just write it from this, and then we have E1, ER, EN, but the I term is missing, right? I term is missing. For I equals 1, the first term is missing. For I equals 2, second term is missing. So this notation means that this term is missing. Bu güzel bir metot. Yani işte şunu ifade etmenin en kolay yolu. Tamam mı? Burada here the first term is missing, second term is missing, third term and nth term. This notation means that this term doesn't exist. So it goes from I-1 to I+1. I term is missing. Now we take this one, this is W, and wedge with V. V is this one. C1, Cn, En, and this is equal to 0. Well, this means what? You see, if I multiply this term with this one, I will get 0 unless the first term is missing. If there's E1 here, when you take wedge product with E1, this term will give me 0. So this will give me something non-zero only with the first term, where the first term is missing. So what I will have is then the following: alpha 1 and then E2 up to En, which C1 E1. This is the first term, plus the second term, C2 E2. This will give me non-zero only with the product, the second term, right? Because if E2 is missing, then the wedge product with that one will give me something non-zero. And the term where E2 is missing is alpha 2 times E1, wedge E3, and so on. So I will have this alpha 2 times E1, wedge alpha 3, wedge E, and wedge C2 E2. And then I'll have plus and so on. So what we will have is the following. Efendim? Yok, orada dikkatli olacağız. So we will have the following. Alpha 1 E2 wedge. I can take, okay, I can take C1 here. Okay, I can take C1 here. I have En and then E1. Plus, I have C2 alpha 2, E1 wedge, E3 wedge, En wedge, E2. And then goes like this up to Cn, alpha 1 wedge, alpha n minus 1, which the last term Cn En. So I have En, not alpha. Nereden çıktı alfa? Yok, burada alfa var. Okay, alpha n, and then E1 with En minus 1. Okay. And this is equal to 0. Now, you see, I have E1 here. I can take it up here, right? It should interchange, right, with n minus 1 elements. So, minus 1 to the power of n minus 1, C1 alpha 1. And then I will have E1 up here. So, E1 wedge, E3 wedge, En, plus
Hocam şurada emin olmaması gerekiyor. En son.
neyin olmaması?
Yani yazdık ya.
Bu şey En'i. Cn En. En son terim Cn En ile bunun çarpımı olacak. Okay. Bu E2 kaç tane atlayacak? It will come up to, okay, n minus 2, C2 alpha 2, E1, and then E2 will come next to E1 and E3, En, and it will go like this up to bundan bir önceki şey olacak. Eksi 1 üzeri burada Cn minus 1 alpha n minus 1 E1 En. Bunun işareti ne olacak? işaret şu olacak. Dikkat ederseniz the sum of this index and this index is n. I mean this is the big N of course. Right? N minus 2 plus 2 is n. So it should be 1. So the sum is 1. And the last one is just C and alpha and E1 with En. And this is equal to 0. This is equal to 0. Ne biliyoruz biz? In the example I did last week, we had something similar, but there we had only 3 terms. I have to find CIs, okay? CIs, because alphas are given. But we know that W is not a 0 vector, because W is not 0. Okay. I shouldn't assume that it is 0. If it is 0, then there is nothing to prove. I mean, you can write 0 vector as a product of n minus 1 vectors, no problem. And you can just choose all of them to be 0. Since W is not 0, at least one alpha is not 0. So I can assume the following. Since W is not 0, we may assume that at least one alpha R is not 0. Without loss of generality, assume that alpha 1 is not 0. Alpha 1 is not 0. Well, you see here, this product is not 0. So this term is the same as this one, right? They are common. So I can write this equation as follows. Then we have the equation. What? Minus 1 to the power n minus 1. C1 alpha 1. And then minus 1 to the power n minus 2. C2 alpha 2. Up to Cn alpha n. And then all this thing is multiplied with E1H En is equal to 0. Well, this implies that this gadget is 0 because this is not 0. And my aim was to find all vectors E so that this product is 0. So I am trying to find CRs, which makes this equation to 0. How can I do this? Well, we can do as follows. Since alpha 1 is not 0, I can write this equation as follows. C1 is just bunların hepsini diğer tarafa atarım. Minus 1. Okay. Minus alpha 1 çarpı right? I write just C1 and then here I have minus 1 to the power n minus 2 C2 alpha 2 and so on up to Cn alpha n. Okay, alpha n. And then we may do the following. I want to get linearly independent vectors. How can I do this? I can just give numbers to these coefficients. For example, let C2 equals 1 and C3 and all others to be 0. This gives me what? If all of them are 0 except this one, so C1 will be what? C1 will be just ne çıkar buradan? 1 koyduğuma göre eksi 1 üzeri n-2 C2'ye 1 koydum. Alfa 2 bölü alfa 1 çarpı eksi 1 üzeri n-1. And there's also negative sign here, so you will get what? N-1, şurası eksi 1 olacak. This gives it x minus 1, another minus 1. So it will be plus 1. So alpha 2 over alpha 1. Değil mi? So we get the following vector. So we get the following vector. C1 is just alpha 2 over alpha 1 P1. And then C2 is 1. Pardon. This is P1, C2 is just 1, P2, and all of this is 0. So V1 is this. V2 will be what? This time, this is what we are going to do. I will let C3 to be 1, C2 and all others 0. So what we will have? I will have n minus 3 here, and then alpha 3 here. Bu sefer aradaki fark 2, burası artı 1, eksi 1, yani şöyle olacak. Bu da ne demek? So, B2 will be just minus C3 over alpha 1 E1 plus E3. Belki şunu şöyle gösterebilirim. I can just also take maybe multiply with alpha 1, so we get this. Alpha 2 E1 which, no, not which, plus alpha 1 E1, E2. And so replace with this vector. Just take some multiple of it. So this is just minus alpha 3 E1 plus alpha 1 E3. And I'll go like this. What will be the third one? Well, third one will be alpha 4 alpha 1 E1 plus E4. So V3 will be just alpha 3 E1 plus alpha 1 E4. I'll keep going like this up to n-2. n-1 tane vektör ihtiyacım var, değil mi? n-1 tane. Zaten şöyle, hangileri? So here I can give values to C2 and then C3, C4 up to Cn. Yani n-1, evet, n-1 olacak. Şunu yazalım, bu nedir? Bu şunu yanlış yazdım değil mi? Bu alfa 4 olacak. Bilmiyorum. Alfa 2, alfa 3, alfa 4. Bu ne olacak? alfa bir fazlası n-1 e1 plus alfa 1 bir fazlası n-1 önünde ama bir işaret olacak değil mi? Nedir bu işareti? Eksi bir üzeri. Buradaki indeks neyse değil mi? Bu şu indeks kadar eksi bir. Yani burası çiftse artı tekse eksi. Tamam. dn-1 ne olacak? dn-1 o da eksi bir üzeri n alfa n e1 plus alfa 1 en. Okay. All right. Yes. So our claim is this. Claim is the following. Our W is this vectors, product of this vectors. V1 dash up to V and -1. Up to a scalar for some number. And once you have this lambda, I can just call this vector as V1 and we will be done. Okay? Yani eğer V1'dan n-1'e kadar bu çarpım W'ye eşitse, burada bir lambda olmak üzere, bu lambdayı ben V1'in içine atarım. Sonuçta bir vektör bulacağım. O vektör V1 vektör değil de lambda V1. So this is our claim. Let's see why this is true. I mean, if this is true. Ben birazcık şöyle. Şöyle. Yine anladım. Neyse. Okay. Şimdi bakalım W ile bu çarpım birbirine eşit. W neydi? W was this catered. So let's see. V1 which V and -1. What is V1? V1 is alpha 2 E1 artı alfa 1 E2 değil mi? Ve alfa 3 E1 artı alfa 3 E3 mü? Yok, alfa 1 E3. Evet. Which alpha 4 E1 plus alpha 1 E4. And then I have -1 to the power n minus 1 alpha n minus 1 E1 plus alpha 1 E n minus 1, and finally minus 1 to the power n alpha n E1 plus alpha n E1. No, E alpha 1 E n. Yes. Okay. All right. So now you see each term here has E1, right? And this one also E1. Therefore, I can, when you start with this one, you will get 0. Even if you don't multiply with this one, but I mean, if you may choose to multiply with this one, öyle yapabilirim. Tabii ki. Dur bakayım. Şöyle yapabiliriz. Buradan alfa 2'yi alıyorum. So I take this term, and then since I have chosen E1, I have to choose this one, this guy, alpha 3. Bir dakika. Buradan İvan alırsam, bunlardan hiçbirinden İvan'ı alamayacağım. Dolayısıyla alfa 2, alfa 1'i alacağım. Buradan da alfa 1'i alacağım. Buradaki şey ne olacak? E1'i almıştım. E1, ondan sonra E3 yapacağım. Pick E4. E n minus 1 and E n. Bir dakika. Yani bir 2, 3. Evet, bir bu terim var değil mi? Yani buradan bunu aldım. O zaman bunu alacağım, bunu alacağım. Bunu alacağım, bunu alacağım ve bunu alacağım. Kaç tane alfa var? Alfa. Efendim?
Eksilikten alfa 1 olacak değil mi? Evet.
Evet. Eksi
Tamam. En
minus 2. Tamam. Artı bir de şu var. I can choose this term. So alpha 1 E2 which
It would like that, right? Whenever I choose E1 that is wedge product, I will have all the terms from E2 of the En minus 1. After E1, I will have E plus 1 after En. I mean, in the E's wedge product, I will have E1 if I choose E1. Before the E1, I will have E minus 1. So it E minus 1.
Okay. Yani buradan şimdi E1'i seçersen buradan şu şekilde gittik. E2'yi seçersen buradan ikisini de seçebiliyorum. Bunu da seçebiliyorum, bunu da seçebiliyorum, değil mi?
E1'i seçinceye kadar mesela 5. yerde seçtik. E1 ve böyle olacak. E2, E3, sonra E1 gelecek, sonra E5, E6 bu şekilde devam edecek. Birinci yerde seçsek E1, E2, E minus 1, bir de E1 gelecek, sonra E plus 1, sonra E'ye kadar.
Hocam 2 yani.
Şöyle yapalım mı? Alfa 1'i ben 1 seçeyim. Evet. Şurada alfa 1 sıfırdan farklı ya. For simplicity, let's choose alpha 1 equals 1. Okay? Yani çünkü her şeyi 1 bölü alfa ile çarptığımızı düşünelim. O zaman şu olacak. So if you choose alpha 2 equals alpha 1 equals 1, you get just alpha 2 of this, and then here this alpha 1s are 1. We don't have this. Okay, so what is the next term? Alpha 1 yok. I have E2 wedged in 3. But then okay, you may have E4. Yes. Up to En. But actually, here you have 1, but that's also alpha 1. And then what else? We could do the following. Yani her bir sanki diğer terimler de gelecek diye düşünüyorum ama E1 var, E1, E3, tamam o var. Bunları çarparken şöyle yapacağım. Her seferinde bir tane okey. Mesela şu var değil mi? Eksi alfa 3 E2 E1 E4 N'e kadar gelecek. Eksi alfa 3 ile minus alfa 3 This is actually, if you interchange these two, it becomes plus E1 2. And if you just keep going, so you will go up to okay. Nereye kadar gelecek? E'nin olmadığı terim. Yani şunu alacağım. E2'den başlayacağız. So, E2, and then I pick up E3 up to En minus 1, En minus 1, and then I have minus 1 to the power n alpha n, and then I have E1 here. Burada da yine bu E1'i şuraya alırsak ama n-1 tane oluyor. Şu çarpımdan bunun geldiğini görmek kolay olması lazım ama bir şekilde göremiyorum onu. Belki şöyle mi yapmak lazım? Peki. So this is just D1 is alpha 2 over alpha 1 E1 plus E2, which minus alpha 3 over E1 plus E3 is which en sonuncusu ne olacak? Eksi 1 üzeri eksi 1 üzeri alfa n over
Alpha 1,
1
E1,
E1 plus En.
N hocam.
Şurası da
N olmuş.
şuradaki katsayı neyse o. Ha. Bunun şu alfa olduğunu yani upper scale let me give break. After the break, I'll continue.